The two properties of charges is that like charges repel each other and unlike charges attract. The electric force between two charged particles is greater than the gravitational force between the particles. The more negatively charged electrons in an atom are held closer to the nucleus because of their attraction for the more positively charged protons in the nucleus. Also, electric charge is neither created nor destroyed, it is conserved. In 1909, Robert Millikan performed an experiment that determined the size of the charge on an electron. He observed the motion of tiny oil droplets down two parallel metal plates. The droplets were charged by friction in an atomizer that traveled through a hole in the top plate. As a result, the droplets fell and the top plate was given a positive charge and the droplets had a negative charge that was attracted back to the positively charged metal plate. To further observe, Millikan switched the plate on and off, and he was able to see thousands of oil droplets for hours. He finally realized that when an object is charged, it is always a multiple of a fundamental unit of charge, E. Therefore, charge is quantized. Also, he discovered that an electron has a charge of negative E, and a proton is positive E, and the value of E is approximately 1.6 times 10 to the negative 19th coulombs. Induction is a process of charging a conductor by bringing it near another charged object and grounding the conductor. Basically, there are two objects whose charges redistribute and through grounding some leave. So the object has less negative and more positive. For example, when a charged rubber rod is brought near a metal sphere, the electrons move away from the rod and the charge on the sphere becomes redistributed. If the sphere is grounded, some of the electrons travel through the wire to the ground. When this wire is removed, the sphere has an excess of positive charge. The electrons become evenly distributed on the surface of the sphere where the rod is removed. In most neutral atoms or molecules, the center of positive charge corresponds with the center of negative charge. If there is a charged object present, the centers could shift slightly. This results in more positive charge on one side of a molecule than the other. The electric force is when two objects near one another experience acceleration either toward or away from each other because of the force exerted on each other. The actual formula of Coulomb's law represents the magnitude of the electrostatic forces of interaction between 2 points of charges is directly proportional to the scalar multiplication of the magnitudes of charges and inversely proportional to the square of the distances between them. For example, the electron and proton of a hydrogen atom are separated, on average, by a distance of about 5.3 times 10 to the negative 11th meters. Find the magnitudes of the electric force and gravitational force that each particle exerts on the other. You first use the formula for gravitational force, then plug in the corresponding values. The final result is 3.6 times 10 to the negative 47th newtons. Next, you do the electric force formula, and then again plug in values, and you get 8.2 times 10 to the negative 8 newtons.